Now let's take a look at example 1. Now example 1 says that there's this examination is marked at 100 marks. Now obviously the minimum of this examination will be 0, the maximum will be 100. It's taken by a large number of candidates, and then you're also told that the mean of the score is 72.1, standard deviation is 15.2. Now you're asked to give a reason why a normal distribution with this mean and this standard deviation will not give a good approximation to the distribution of marks. Now, if x is what I will call the mean, the number of marks of this examination, and if I say that x is a normal distribution, okay, with this mean 72.1 and the variance 15.2, take note now, is 15.2 square. Okay, now why square? If you recall, this slot is for sigma square, the variance. It is not for sigma. Okay, please note this. This is a very common student mistake. Now going back to the question, if this is going to be a good approximation for the distribution of marks, then what does this mean? It means that I can draw a rough sketch here. I can draw a bell curve here with mean 72.1, and if I were to look at mu plus 2 sigma, okay, and mu minus 2 sigma, in particular, this particular endpoint, 72.1 plus 2 times 15.2. Now this number, right, is going to exceed 100. Now if this number is going to exceed 100, we know that this is impossible because the exam is marked out of 100 marks. And why is this no good? The reason is because, remember what we said earlier about this area. This area, if I look at the boundary of mu minus 2 sigma and mu plus 2 sigma, the area under the curve is actually 0.95. Okay, now that means that 95% of the marks is bounded between mu minus 2 sigma and mu plus 2 sigma, and going above 100 is impossible. So that's why the normal distribution x will not give a good approximation to the distribution of marks. Okay? Now in this new section, we will learn about how to use the GC to calculate probabilities. Now remember, earlier on, we talked about this. We talked about probability, your x between A and B. How to find this probability? We will have to use the GC to find area. Okay? Now instead of using the integration function, now your GC actually has got just like your binomial and Poisson distribution, it has got this normal CDF, okay, that is built into your GC for you to calculate this probability. Now we look at a very simple example. Now if I say that x is a normal distribution, okay, with mean 10 and variance 4, then if I want to calculate the probability of probability x less than 8, then what I'll do is I will use my GC to call out this function, normal CDF. Okay, and then once I do that, this screen will appear. So all I need to do, right, is to key in the numbers that I want to find into the screen. Now, I should always think of this piece here. I should always think of this. Okay, the lower limit is this number here, and the upper limit is this number here. So if I want to find probability x less than 8, now actually what you should be thinking of is this. Okay, so this piece here, the lower limit is minus infinity. So what the GC has already, I think by default, okay, has this number there. Now this is just a very negative rather a very small negative number. Okay, so this is to tell the GC that this is minus infinity, and then this number here is the number that I want to find, 8. Okay, or rather the probability with the upper limit that I want to find, and then I'll key in my mu, I'll key in my sigma. Remember, this is sigma. Okay, again, this is a very common student initial mistake. The sigma, okay, is not seen immediately because this number 4 is sigma square. So that's why your sigma is just square root 4, which is just 2. Okay, so that's why I key in 2 here. And once I key in all this, I will click enter. Okay, and then I will see this on my screen, and this is my answer. Okay, practice this on your own. I think the instructions here are very, very clear. The things to remember is always this: your CDF, norm CDF, okay, is used to find this. Okay, is used to find this. So your B and your A are your upper and lower limits. Okay, your upper and your lower limits. Now, if you have this, for example, x bigger than A, okay, x bigger than A, your upper limit is infinity. So infinity is represented by a very huge number. So your GC, okay, has got this really big number, e to the power of 99, or rather exponential to the power of 99, to mimic a positive infinity. Okay, so you can try this out on your own to get these answers. Okay, I think the instructions are very clear. Now, example 2, right, is just practice for the earlier section. Okay, if you've understood the earlier section, then example 2 just allows you to use your GC, okay, to practice computing normal CDFs. Okay, now example 2 says that you have this normal distribution, x follows normal, has got mean 100 and variance 25. Now usually I will tell students this, it's always a good habit to think of 25 as 5 square, so that later on when you key in your sigma into your GC, you don't key in 25 but you key in 5. Okay, now A says that you want to find the probability of x between 95 and 105. 95 is my lower limit, 105 is my upper limit. So what do? I first call up the function normal CDF, okay, using second variables. Then once I do that, this screen will appear. Okay, this screen will appear, and then I have to key in the lower limit and the upper limit, the mean, as well as, again, not sigma square but sigma, okay, which is 5 here. So I press enter, and then the answer will appear. Okay, the answer will be 0.683. Now, you should try B, C, and D on your own. Okay, it's actually very easy. Okay, the screenshot for B is shown in your notes. Okay, you can follow the same instructions, call up the normal CDF function, and then key in. Okay, for B, okay, remember it's actually from minus infinity, okay, x, and then 95. Lower limit is minus infinity, upper limit is 95. So you call up your normal CDF, and under the part for the lower limit, you just key in a very small negative number. Okay, the default number is minus exponential to the power 99. Okay, so you just leave it as it is. The upper limit 95, mean 100, variance again is not the number you're supposed to key in here, it's supposed to be the standard deviation. So you key in 5, and then you just press enter twice, and then you have your answer. Okay, so do it for part C and part D. Okay, part D, okay, you may want to take note that you can rewrite this piece here, okay, as a sum. Now, why do I say that? Now, if you look at this piece here, okay, you draw a bell shape. Now, I'm interested in x values bigger than 103, okay, this shaded region here, and x values less than 95, okay, this shaded region here. So this is the same as the two different areas under the graph add together. Okay, why do I say that? Because of this word or. Now I want to find either this or this, and these two events are mutually exclusive. So I can actually break up, okay, the single probability on the left into two different probabilities on the right, and then look at this and look at this. These are two CDFs that I can key out individually on my GC to get this as the answer. Okay, try this out on your own. It shouldn't be too difficult.